So we can recall the X and Y axis where we have quadrants 1, 2, 3, and 4 in that order, where this axis is called the X axis, and then we have the Y axis. And then recall that if you have 2 points on the XY axis, that you can find the slope between those 2 points based on this pattern here. M is the letter that has been selected to represent the slope of a line that connects 2 points. And this here is how we find the slope between those 2 lines, or between those 2 points rather. Oftentimes we refer to this as the rise over the run, where of course, if you have a line that runs like this, the slope is said to be positive, where if the slope runs like this, the line is said to have a negative slope. And if your line is perfectly horizontal, the slope is 0. And of course, if your line is vertical, the slope is said to be undefined. And let's run through some exercises here. So for instance, sketch the graph of x equals 4. When you have x equals, the line that you're going to get is perfectly vertical. And so what you do on the x-axis is you go to that location 4. And then what you do is you draw a vertical line that passes through x equals 4. That's the line that goes with this equation. What about this one here? Y equals -2. Well, for that, we go to the y-axis. And then we go to -2, which would be down here. And the line that we draw would, of course, be a horizontal line. Okay. What about this one here? X equals pi. Well, given that it's x, we're prepared to draw a vertical line. And since it's pi, pi is famously a number that's a little bit bigger than 3. And so maybe something to this effect here would be sufficient. So there it is. That's how you graph the equation of a line that is either perfectly vertical or perfectly horizontal, where a vertical line has a slope of undefined slope, and a horizontal line has a 0 slope. But of course, this gets more interesting when you have lines that are not either horizontal or vertical, but rather when you have lines that have a more interesting slope, either like that or something like this. And for that, we need some equations. You see, these are the 3 most commonly used versions for writing the equations of a line. The equation of a line could look like point slope, slope intercept, or standard form. This is what those forms look like. Let's do some examples here. I have 4 specific examples that I'd like to get through. And these 4 examples cover these concepts here. So let's see, why don't we begin with this problem here. We're given 2 points and we want to find the slope between these 2 points. What we did in class was we could label these points x1, y1, x2, y2. And then we could apply this arrangement here. This slope formula could be applied to these 2 points. And so we can go m equals, and then we follow the arrangement that is here on this paper. We would go, let's see, so this would be y2 minus y1. So we'd have -3 minus 7. And then in the denominator, in the bottom, we'd have x2 take away x1. And we know what happens here. This interaction leads to a positive. And so that we get here, we get -10/8. And if you can reduce a fraction, we would prefer that you did. And so this here is the slope. Alternatively, how else could you have done this problem? You could have gone to the x and y axis like we did last time. You could have plotted these points here. For instance, if I just do this quickly, this point there would be like right there somewhere. And this point here would be like down here somewhere. And then notice that if you connect them, that would be a negative sloped line. And then you would have gone down 5, which is this guy. And then you would have gone to the right 4, which is that one. So you could have done this a couple of different ways, either algebraically with the formula or sort of visually by graphing. Totally up to you how you do these problems. Up next, write an equation as point slope. So we want point slope, and they tell us that our line has this slope here and that we pass through this point. So we know what point slope looks like. Y minus y1 equals m times x minus x1. Let me jot down that formula one more time. So this is what we want to play with here. Okay. And we know our slope is negative 5/7. So that is going to go in for m. And then our given point, whatever point we pass through, whatever point we happen to contain, we can call it x1, y1. And so replacing x1 is going to be the number 1. And then replacing y1 is going to be the number negative 9. So let's make these substitutions. And it looks as though this is what we get here. And of course, we can change that double negative to a positive. And so this would be the result that we submit to them. This is an equation in point slope form that has a slope of this and that passes through this point. So they call it point slope because you need a point, boom, and you need a slope right there. What about this one here? It says, right, the slope intercept. Okay, so slope intercept is the very famous y equals mx plus b. Y equals mx plus b. That's what we want. And what are we given? So we want slope intercept, and we're given 2 points. Well, let's see. They call it slope intercept because m is your slope, and b is the y-intercept. The y-intercept is wherever this line crosses through the y-axis. So let's see. To get started here, we need the slope m. And lucky for us, we know how to find the slope. This is our formula. And we do have 2 points. Maybe we can label them. Let's call this x1, y1, x2, y2. So maybe before anything else, what we can do down here is we can find the slope between those 2 points as some scratch work. So our slope m would be y2 minus y1 over x2 minus x1. Careful with that double negative. That looks like this would be 14 over negative 7. And it looks like the slope would be negative 2. So we know our slope m is going to be negative 2. Now that's what our slope gave us. So we can update our formula a little bit. We have found m. All we need now is to find b, and we're finished. And in order to find b, what we can do is we can pick either of the points. Let's say you randomly selected this point here. If this is the point that you pick, then what you can do is take this number and plug it in for x. Take that number and plug it in for y. Right there and right there. We're making these temporary changes. Temporarily, x will become this number. Temporarily, y will become that number. And we're doing this so that we can discover the value of b. And I randomly chose this point. I could have chosen this one. It would not have mattered at the end. So let's see. Instead of y, for now, let me write 5. And just for now, instead of x, let me change it to negative 1. And now let's solve this equation for b. Negative 2 times negative 1 is 2. If I subtract 2 from 5, it's going to say that 3 equals b. And so now what we can do is we can take this number, and it's going to replace b. And so it looks like our final answer here would be this right there. And if you wanted a really quick sketch of this graph, what you could do is go to the x and y axis, and this is what the graph would look like. You see the number in the back, the y-intercept, b, had a value of 3. So we'd go 1, 2, 3 on the y-axis, and you'd put a point there. And now the slope was negative 2 over 1. So from up here, you can go down 2 to the right 1. Down 2 to the right 1. And you could do that pattern forever. You see, that is what this line would look like. Right? This equation looks like this. And furthermore, this line passes through this point and through this point. Okay, let's try one more. How about this one here? So now we want standard form. and we're given 2 points. So let's see, standard form is this guy down there. It looks like ax plus by equals c, and a, b, and c have to be integers, like no decimals, no fractions. They have to be solid numbers. They can be positive, negative, or possibly 0, but no fractions, no decimals. So I always tell my students, if you want to get standard form, focus on slope-intercept. Spend all your time building this, because we can very, very quickly go from here to there. So for now, I want you to pretend that you're doing the previous problem all over again. Let's just run through these steps so we can build slope-intercept, and then I'll show you how to go from here to here, like that. And so we can first find the slope between those 2 points, like we did in the previous problem. So we can call this x1, y1, x2, y2, or vice versa, doesn't really matter. So first order of business would be to find the slope m. So let's go y2 minus y1 over x2, take away x1. Let's change this double negative to a positive. That would be negative 8 over negative 15, it looks like. The double negatives turn into a positive, and so we have our slope m. And so again, we're focused on slope-intercept form. So right now we want y equals mx plus b, but we know what m is. We just made that discovery, 8/15. And so this is what we have right now. And we have to discover the y-intercept b. And so we select either of the 2 original points. Again, it doesn't matter which one you pick. Let's say that I pick this one here. So I'm going to plug this in for x and this in for y. And so I would get, let's see, so let me do that work up here. So instead of y, I have negative 13. And then I have 8/15. And then instead of x, I'm going to write 3 and then plus b. So this is negative 13 equals, on a calculator, this would be, it looks like it's going to be 24 over 15. And I can subtract 24/15 from both sides. These are gone. And let's see what that would be on a calculator. You guys should absolutely bust out your devices. Let it do all the arithmetic for you. You really should. It says negative 73 over 5. And so we've discovered that our y-intercept b is this strange number here, this fraction. And so that goes in for b. And so it looks like our equation looks like this so far. And so here is where I want you to focus. I want you to focus on this equation right here. Let me just separate it from everything else. So what we have looks like this right now. Our equation looks just like this, but we want this here. How do I go from here to here? Well, notice how this is built. This has the x's on the left-hand side, while this equation has the x's on the right-hand side. So what we're gonna do is we're gonna take this entire bit and move it to the front. Now, if this piece is positive on the right, when you move it to the left, it's gonna become negative. And so by subtracting this to this side, it'll be negative 8/15 x, then your positive y, and then that weird number on the other side. So it looks like everything is in the correct spot. You have the x's, those are the x's. You have the y's, those are the y's. And then you have some number c. However, we're not done, because the requirement is that a, b, and c, they have to be integers. An integer is like 5, 10, negative 30, numbers with no fractions or decimals. But unfortunately, we have some denominators. So I want you to look at those denominators themselves. This says 15 and this says 5. And whenever that happens, when you want standard form, you got to make these integers. So think of how you can manipulate this equation so that 15 and 5 disappear. Your teachers have always told you in the past that whatever you do to one side, you do to the other. So let's make a decision here. I'm going to multiply both sides by a very special number. I'm going to multiply both sides by, well, what number do you think we should use that would knock out these denominators? Somebody might say multiply by 5. I could multiply both sides by 5. And if I multiply this side by 5, it would knock out the 5 in the bottom. But if I multiply this side by 5, the 15 would not be knocked out. So think of a number that you can use that will simultaneously knock out not only the 15, but also the 5. You make that decision carefully. Can we agree that the number 15 itself would actually work? Because 15 is going to knock out 15, and then 15 will also knock out 5, because 5 can go up into 15. So let's see. Let's distribute. This times that, the 15s would knock out. It would just be the negative 8x. This times this would be a positive 15y. And then this times this, I will rely on my calculator here. It says negative 219. So that was quite a bit of work for this last problem, but there it is. This is a line, and it's going to pass through this point and through this point. So this is one way to do problems that look like this.